Hi, welcome back. Hearty welcome to you. So this is our last session on inverse trigonometric functions. So we have covered almost all the type of problems. So let's try to see how the competitive exam problems are with respect to inverse trigonometric functions. So some simple problems I have taken so that we can apply the concepts whatever we have learned. So let us see how much we are able to solve them. Okay. Now we have to prove that cos of tan inverse of sine of cot inverse of x equal to square root of x square plus 1 by x square plus 2. So what we will do, first we will take this as alpha, then we will get sine alpha. By this substitution we know x equal to cot alpha, so we will find out sine alpha. Again we will find out whole this value, again we will take it as another angle, tan inverse something as beta, then we will find out what is cos beta, that should be equal to this. So let's go ahead and do that. Okay, excellent. I will write it as cos of tan inverse of sine of, I'll put this cot inverse x in another color so that you will understand. Cot inverse x, I will take this as alpha, so that becomes cos of tan inverse sine of cot inverse x is alpha. Now this substitution, by this we know that this substitution gives us that x equal to cot alpha. So let's see here, this is alpha, I have cos by sine cot. What is cot? Adjacent by opposite, that means this is x, this is 1. So what this will be? Square root of x square plus 1 by Pythagoras. Now what I have to prove here? Cos tan inverse sine alpha, that's nothing but cos of tan inverse of, I know what is sine alpha. Maybe I'll put this in different color so that you know what we are going to do now. Tan inverse of sine alpha. What is sine alpha here? 1 by square root of x square plus 1. Right. Now let us say this whole thing is nothing but equal to beta. That gives me tan beta is equal to 1 by square root of x square plus 1. What is that? Let us check what is that. We'll have beta here. Tan beta is opposite by adjacent, that is this is square root of x square plus 1. If you do, this is nothing but equal to square root of x square plus 2, because I have to square this, that's x square plus 1. I have to add this square, that is x square plus 2. I should find out the square root. Now what is this becoming? This is becoming cos of beta. What is cos beta from the figure? Cos beta is nothing but adjacent by hypotenuse, that's nothing but equal to square root of x square plus 1 by x square plus 2. So what we have done? We have taken first cot inverse x as alpha. By that I know x equal to cot alpha. Now I have kept alpha here so that sine alpha is there. If I know cot alpha, I found what is sine alpha. Now again I have tan inverse of something. Again I have taken it as another angle beta. From that I know what is tan beta, but what I have to find out is cos beta. If I go for Pythagoras of beta, I know what is nothing but cos beta. Okay, we'll solve the next. Let's look at the second problem now. I have to solve for x. What is given to me? Given to me that sine of 2 cos inverse cot of 2 tan inverse x is 0. I hope I will remember that. Sine of, see, no, 2 cos inverse 2 cos inverse cot of 2 tan inverse x equal to 0. So I have to find out what is the value of x. I have to solve for x. I have to solve for x. This is second part. How we will do that? Let me go ahead and try to solve that. Okay. Now what I will do as it is 2 tan inverse x, I will take it as tan inverse x, I will take it as alpha. That means x equal to tan alpha. So what this becomes now? This becomes a sine of 2 cos inverse cot of 2 alpha equal to 0, because tan inverse x you can substitute with alpha. This becomes cot 2 alpha, right? Now you know x equal to tan alpha. What is cot 2 alpha? Cot 2 alpha is nothing but 1 by tan 2 alpha. And what is tan 2 alpha? Is nothing but 2 tan alpha by 1 minus tan square alpha. Tan 2 alpha is equal to 2 tan alpha by 1 minus tan square alpha. And this is nothing but 2x by 1 minus x square. So what is this becoming now? I have sine of 2 cos inverse. What is cot 2 alpha? Cot 2 alpha is opposite of this. That's nothing but 1 minus x square by 2x. This is what is equal to 0. Now let's see. Now I have to find out what is cos inverse of this. Again I will say that this is nothing but equal to my beta. So that gives me cos beta is equal to 1 minus x square by 2x. You are okay with that? What we are doing, wherever inverse is there, we are taking angle alpha, and by that we know one relationship. Now if we substitute alpha, we have to find out the what is the trigonometric ratio of that particular angle. So now what I have to prove at the end? I have to prove just simply sine 2 beta. I know cos beta equal to, let's do it here. Let us do it here. I have to prove sine of 2 beta, sorry, I have to solve for sine 2 beta equal to 0. I know cos beta equal to 1 minus x square by 2x. This is nothing but 2 sine beta cos beta equal to 0. That means 2 into sine cos beta I will write as it is 1 minus x square by 2x into cos beta. You can see cos beta is nothing but square root of, this is sine beta, so what will be cos beta? Cos beta will be nothing but 2x whole square minus 1 minus x square whole square equal to 0. Now if I square everything, I will have 4 into, I can say x square minus 1 whole square into, this is nothing but a square minus b square. So I can write it as a plus b into a minus b. That is, I can write, if I take this as a plus b, or okay, so it will be x minus 1 whole square minus, okay, 2x square, then it will be 2x, 1 will be 2x plus 1 minus x square, and another will be 2x minus 1 plus x square. So nothing but you will have x square minus 1 equal to, this whole thing is equal to 0. If I take x square minus 1 equal to 0, x equal to plus or minus 1. What are the other equations I have? X square plus 2x minus 1 equal to 0, and another one is x square minus 2x minus 1 equal to 0. If you solve these two by quadratic equation, substituting ax square plus bx plus c, the equation, the value roots are x equal to minus b plus or minus b square minus 4ac by 2a, you will get plus or minus 1 plus or minus root 2. So these are nothing but the values of x, either plus or minus 1 or this one. You can cross check that. If I say minus b2 plus or minus b square 4 minus 4ac, that is plus 4, 4 plus 4 is 8. So 2 plus or minus 2 root 2 by 2, 1 plus or minus root 2, and this will give you minus 1. So it is nothing but either plus or minus 1 or plus or minus 1 plus or minus root 2. I hope you got it. That will culminate our inverse trigonometric functions. We'll go to the next chapter, next topic, that's hyperbolic functions, maybe in 2-3 days. Okay? Thanks for visiting. Bye for now. We have just seen some competitive exam questions, and are we able to solve them with the knowledge whatever we have? And we have seen that pretty much this knowledge is enough. If we have foundation, we need to practice for competitive exams. Thanks for visiting. Bye for now. All the best. See you in the next video.